This is mathheals.com, where you can find more links to math YouTube videos and computer science. Let's take a look at relations. For purposes of what we're going to be looking at, we'll be thinking of points, where we tie x to a particular y value. Take a look at our first problem. And we got the points 2, 3, 4, 5, 8, 1, and 9, 2. And it says write each relation as a map, then identify the domain and range of the relation. Well, I'm going to put my x values here, my y values here. Now I'm going to write them down, and I'm not going to repeat any, and I'll go from smallest to largest. So I got 2, 4, 8, and 9. I'm going to circle them. Different books do maps different ways. Now over on this side, again, I'm going to write down my y values from smallest to largest, not repeating any. So I got 1, 2, 3, and 5. Now for this one, this maps 2 to 3, so I'm going to draw a line between 2 and 3. This maps 4 to 5, so I draw a line between them. 8 to 1, draw a line, and 9 to 2. And that would be our map. Now domain is your x values. And we'll see it's a little bit more than that once we get the graphs and so forth. But your x values here would be just what we have listed. So I got 2, 4, 8, and 9. And your range is your y values. And that's what we got listed here. So we got 1, 2, 3, and 5. And those would be our answers. Now, we'll see once we get to more exciting problems that the domain, your x values, is your independent variable. You can put anything in for it. And then the y values is your dependent variable. And it's dependent upon whatever you put in for x. So if you put this in for x, and we'll give you this for your y. But for purposes of algebra, domain is always your x values, range is your y values. Let's look at another map. 1, 2, negative 1, negative 2, 3, 2, and 5, 1. Okay, so we go from negative 1 to 1 to 3 to 5. I'll circle them. And our y values. Looks like our smallest one is negative 2. The next one is 1. And then the next one is 2. Okay, 1 maps to 2. So 1 maps to 2. Negative 1 maps to negative 2. 3 maps to 2. 5 maps to 1. So that's our mapping. Now for our domain, we're going to list our x values from smallest to largest, not repeating any. So negative 1, 1, 3, and 5. And our range, same thing. Negative 2, 1, and 2. And those will be our answers. Now next one gets into a graph. So let me put a little bit more of a definition down on domain and range. Domain is your x values where your graph exists. And your range is your y values where your graph exists. Okay, so for this one, it's -2, -1, and 2, 3. Okay. Our domain is our x values where our graph exists. If I come over here to -3, if I go up or down, can I find my graph anywhere? No, it's nowhere. The graph doesn't actually begin until -2, so that's leftmost x value. So it starts at -2. If I come over to here, if I could come over to 3 or 4, if I go up or down, can I find my graph anywhere? No. The rightmost x value where it exists, if I come straight down from my point, is 2. So x value wise, the graph only exists from -2 to 2. Now, we're going to put brackets here. Brackets means it includes those numbers. Now, it'll always be bracket unless there's an open dot here. And I don't know if we have an example of that in this section, but it would look like this. One's a closed dot on this side, and this one's an open. Now, our range. Our range is our y values where our graph exists. Well, if I come down here to -2, if I go left to right, I don't find my graph anywhere. But if I go to -1, I find my graph. That's actually my lowest y value where the graph exists. And then the highest y value, if I come up here to 4, if I go left to right, I don't find my graph anywhere. The highest is right here. It's like you take your highest point and you go over to the y-axis and see what it equals. So that'd be 3. And these will be brackets again. So that's our domain and range for that problem. Let's look at this. Oops, spelling check. No, I went too low. Let's take a look at this problem. I'm not going to draw it, but it's best probably to look at this. Okay, our domain is our x values where our graph exists. Well, this is the leftmost part of our graph right here. And I give you the point here. It says 1, -4. So if I would even go straight up from here, I'd see it's x equals 1. Graph doesn't exist over here anywhere. So leftmost x value where the graph exists is 1. The rightmost x value where your graph exists. If I come, this is my rightmost part of my graph. If I go straight up from there, it's 3. You can also see it in the point. So it goes from 1 to 3. Now these are open dots, so I'll put brackets on them. Now our y values. Lowest one where it exists. This is my lowest part of my graph. If I come over here, you see it's -5. And this is my highest part of my graph in terms of y value. So if I go over here, you see it's -3. And again, there'll be brackets on those. Let's take a look at the next one. Now see how there's a dot here, and then this just appears like it just stops at the edge of the graph. When they just appear like they stop at the edge of the graph, they're actually going on forever. Okay, x values. If I come over here to x equals 0 or x equals -1, my graph doesn't exist over here, does it? The leftmost x value where my graph exists, this is where my graph starts, is 1. Well, if I come over here to 3, I can go up and find my graph. It exists there. If I come over to 4, I can come up and find my graph. It exists there. If I come over here to x equals 8, if I go up, I will find my graph because this is going forever. Now, listen to what I just said. It's going forever. Well, that's going to x value-wise to positive infinity. Bracket on the 1, and infinities you can never reach, so that's parentheses. Now our lowest y value where our graph exists, we're down here at 1. If I go left to right, I don't find my graph anywhere. The lowest y value where it exists is 2. Now it's going up here. It's here, y is equal to 3. I come over here, y is equal to 4. Now it's still going up. It's going up slowly. So eventually it's going to slowly go up forever, which is infinity. Now bracket on 2, and infinities always have parentheses on them. Well, let me grab a drink, and then we'll take a look at this one. Here they want you to graph it first, and then tell the domain and range from the graph. So let's plug this into our graphing calculator. Okay, so I'm going to press y equals, press clear. I was already there, but I like to see for you to see the buttons here. Now this dash is the very beginning of our problem, so that's a negative. So we'll do negative 5x. And this dash is between two things, so this is a minus. So minus 3. And then graph. Okay. Number 6. Our domain and our range. X value is where the graph exists. If I come down here to x equals negative 3, if I go up, I can find my graph. Now notice this goes off the screen. This is going forever. So if I come over here to negative 10, if I go up, I have to go up far enough, but if I go up, I'll eventually find negative 10. It actually, if I come over here to negative 1 million, over here somewhere, if I go up far enough, I will find my graph. Is this going forever? Now x equals 1. I can go down and find my graph. If I come over here to x equals 5, if I go down far enough, I'll find my graph. If I go over to x equals 1 million, if I go down far enough, I will find my graph. Is this going forever? So x value-wise, it exists from negative infinity. Oops, try it again. Put the comma too soon. Negative infinity to positive infinity. Infinities always have parentheses on them. Now our y value. See how this goes down forever? Well, that implies that it's going to encompass all the y values. So it's going to go from negative infinity. And see how this goes up forever? Well, it's pretty obvious it exists at every y value. You know, up here at y is equal to 20. If I go left, I can find my graph. So it exists up there. So it's going to positive infinity. And parentheses on those. Look at number 7. Y is equal to x squared plus 3. Same instructions. Yeah, I'll press my y equals, press clear. My x key, x squared plus 3. And then graph. Okay, so our domain and our range. First our domain, our x values. If I come over here to negative 2, I can go up and find my graph. It exists there. If I come over here to negative 3, I can go up and find my graph. It exists there. It actually, even though it's going up like that, it's slowly inching out to the left. So it'll keep slowly inching out to the left. So if I come over here to like negative 10, for example, if I go up far enough, I can find my graph. It actually will keep slowly inching to the left forever, which forever, of course, is negative infinity. Same thing on this side. It exists at x equals 2. It exists at x equals 3. If I come over here at x equals 10, if I go up far enough, since it's slowly inching out, it'll eventually, I'll find my graph up here somewhere. So this is going to positive infinity. Now our range is our y values. Let's come down here to y is equal to 1. If I go left or right, can I find my graph anywhere? No, it doesn't exist down here. The lowest y value where it exists is right here at 3. So this is going to go from 3. And you can pretty well assume it's a bracket. If you don't see an open dot, it's always bracket. And it's going up forever. Up forever in terms of our y values is positive infinity. Let's look at number 8. Yeah, y is equal to negative absolute absolute value of x minus 3. Okay, I'm going to press y equals, press clear. This little dash is the very beginning of our problem, so that's a negative. So negative. Now absolute value is under the math. So press math, right arrow to num, enter on ABS, put in my x key, closing parentheses, and then minus 3. This dash here is between two things, so that's a minus. And then press graph. Okay, our domain and our range. X values. If I come over here to negative 3, I can go down and find my graph. If I come over here to negative 6, 7, whatever that is, go down, I can find my graph. It goes off the screen, so it's actually going down forever. And it's going to the left forever. So this will be negative infinity. Excuse me. And doing the same thing on the right side, going forever. Okay, y values. Well, this is obviously going down. And so it'll keep going down forever, so it'll encompass all the y values down here. So that's negative infinity. Now look at the highest y value where our graph exists. It looks like negative 3 if my eyes aren't deceiving me. So that'll go up to negative 3. Bracket on negative 3, parentheses on the negative infinity. And those will be your answers. And number 9. Y is equal x to the third plus 1. Let's graph that. Y equals clear x caret 3 plus 1. And graph. Okay. Our domain and our range. Our x values where our graph exists. Well, here's, I don't know, negative 2. Is that? I think that's negative 2. Go down, I find my graph. If I go to negative 3, if I go down, or negative 4, whatever that is, I can find my graph eventually. See how this is slowly inching out to the left? Well, slowly inching out to the left means it keeps slowly inching out to the left and will eventually go to negative infinity. See how as this goes up, it's slowly inching to the right? It'll keep slowly inching to the right forever, which goes to positive infinity. Now the y values are pretty easy to see. See how it goes almost straight down. Not straight down. Almost straight down, which means it goes to negative infinity. And this goes pretty well straight up, so you can see it goes to positive infinity. And those would be our answers. And the end of that section.